Hello everyone, welcome back to our course on computer vision. I am Kaustav Tripathi, your instructor, and today we are going to talk about erosion and dilation in images. How we can erode the images or dilate the images. So by the word, I think you got a good idea like erosion. If we talk about erosion, then erosion basically means is thinning out something. And when we talk about dilation, then dilation means thickening something, So in images, when we talk about erosion and dilation in terms of images, we basically talk about, thinning the boundaries in the images. Whatever the boundaries, edges that image have, we will thin it out, or in the terms of dilation, we're going to thick it out. So wherever we really need some kind of a good edges, we use the dilation. Where we want to thin out the edges, we use the erosion. So it's a very simple concept. Let me show you on Spider ID how we're gonna do it, and we're also gonna learn two or three more different things with the format, with the mixing of erosion and dilation. So let's get on to a Spider ID and see how we can do all of this. Okay, so here we are. I've imported two libraries, CV2 NumPy, and I have used this image Linux logo.jpg. Let me show you what this image is. First, let me zoom it out. Okay, so this is this image Linux logo. Okay, we are gonna use this image, and to understand this concept erosion and dilation. Okay, so first we'll talk about erosion. I'm gonna write the whole program related with it. Uh, for the erosion, we use one method called cv2.erode, and this method takes certain parameters like first it takes the source image, so we're gonna give it image. Then it takes uh, kernel. It requires a kernel and with this image, because when we talk about erosion, wait a minute, let me just comment it and show you. Okay, suppose this is our image, and if we are talking about erosion, means we are thinning out the images. Now to remove or to add something in the image, we need a kernel that will process that much of the pixels at the time, and it will pre-process those images. So while doing these things, we need a kernel, and to create a kernel, we have already know how to we can create a kernel of our own. Let's say kernel variable, and by the numpy method of np.once, we will create our own kernel of size, either 3 by 3, 5 by 5, or 7 by 7, your choice. I'm going to take it 5 by 5, comma np.uint8. Okay, so we have created our own kernel. Now I'm going to remove the comment from here. Yeah, we're going to take the kernel. Then the third parameter it takes is iterations, like how many time it is gonna work on that image. Okay, so mostly we use iterations for the ones, but if you need, you can increase the iterations. Like something is really thick and you want to thin it out, then yeah, you might need more iterations, but right now we're gonna go with the iterations one. Okay, now this is called erosion. Right now we are doing eroding. Okay, now let's talk. Also, I'm going to create a program for dilation also. So it's simple. It's cv2.dilate method, and in this we give parameter image, comma same thing, kernel and iterations, and there are also iterations one. So okay, we've created a program for erosion and dilation. Now I'm gonna im show it, cv2.im show. Okay, now for dilation, okay, so let's run this program. Let's see what happens. Oh, wait a minute. Let's run this program. Now you see, this is the original, the original image, Linux in the center, and in the left hand side, the right hand side, sorry, you see this is the erosion image. What it did, it just thin out all the edges in this Linux word written over here, And even in the bottom, section, you see there's something written. It's very hazy, and it is almost removed it because it's really small. Okay, and it has just, see here in L, this section, it is very thin over here, so it almost removed it from here. Same way for this X line, it is thin, so it got, removed. So this is how it worked, and it eroded the. Now this amount of erosion depends on two things: on the kernel size and the number of iterations you use. So right now we have used a kernel of 5 by 5. If you use a different size kernel, maybe you won't just diminish this. You can still see it like a very thin line. Okay, so this is erosion. Now if you see this dilation over here, now what it did, it adds the, you know, it takes out all the edges in this image. All the boundaries over here, it is just thickened out. That's why this N and U almost merged over here. This X look a lot thicker. Okay, so this is erosion and dilation. Now there are two more things with this. They're like opening and closing. These two terms are used, opening and closing. Now opening is like, first it will do a erosion and then it will do a dilation on that eroded image. And same ways for the closing, it's the opposite of it. For it, what closing does, it will first dilate the image, means make all the boundaries thicker, and then it will do the erosion on it. So let me show those two examples over here only. Image 3 is first in this, the method is uses morphology X, and it also takes parameter image, original image, and then it takes a method cv2 dot morph open for opening, and then the kernel, what are the kernel size we are providing it. And for the closing, same thing is cv2 dot morphology X and image comma cv2 dot morph close comma kernel. Now if you see, one thing I want to tell you, okay, let me show you. Wait a minute. Okay, it is not showing right now. That list, I was kind of thinking, trying to show you all those morph methods that are present over there. Okay, I'm going to give you the important ones. I'm going to tell you important ones. This erosion, dilation, morph open, morph close, but rest of them, try it out. And if you couldn't work with them, if you find some problems, then put it in the comment section. I'll make a video on them too. Okay, but right now I'm just explaining these four concepts. These are important concepts, and rest are all like bystanders of it. Okay, so I'm show these both of them. Image 3 and cv2.am show for that closing. Now these are all of them. Now this you see here, this is the original image. Okay, and we have already talked about dilation and erosion over here. You see these two are erosion and dilation in the right hand side, and these are opening and closing on the left hand side. Okay, now I told you opening is when we first do the erosion and then we apply a dilation on the image. So what happens here, first it eroded, like in the right hand side it did the erosion. Okay, lots of things were removed, like this section, a little bit of this section is all being removed. Okay, then dilation is being applied. Now dilation is applied on the boundaries, okay, wherever the boundary is present, but in some certain areas the boundaries is almost over or finished, there is no boundary over there. So that means whenever when it was dilating it, so it couldn't find the boundaries and it left those areas. Like you see here in the L, it leaves the certain area, and same way here it leaves the certain areas, but wherever it finds the boundaries, it has thickened it all. Okay, same way when we talk about closing means first it will dilate the image, it will cover out all the boundaries, make them thick, and then it is gonna work on erosion. So you see here it has thickened out all the boundaries so that they can be properly visible and does not much get affected or get diminished while eroding. And then when we eroded it, you see here as I told you, it almost looks like the original image, just with little bit of deformities. But you see, all the lines were thickened first of all, and then they were worked with the erosion. So it almost looks like the original image, but not a complete original image because it couldn't decipher it as a boundary between N and U because they both are merged together. So it just couldn't detect that there is a boundary between N and U. So that's why it couldn't, work that properly, or the boundary between L and I over here. So basically, dilation, these closing or opening, all this erosion dilation, when we work with, when we want to create some edges, or we are unable to find a very proper edge over there, and we want it, we want that edge, so we use a dilation to thicken out those edges and all. So this is all in the erosion and dilation, and there are other methods, morphology methods. There are lots of morphological methods. If you wanna, just work with them, and if you find a problem, if you couldn't understand them, then you can put in the comment section. I'll make another video on it, and there will be a link in the description with these all morphological concepts that you can visit there. They have explained it pretty well, I'm sure. Okay, so see you in the next video.